replace here with 3 minus 10. Is 3 minus 10 squared plus 60, which will be V3 squared minus 20, V3 plus 100 plus 60. So we can come to this, right? V0 negative 20 V3 plus 160 is 0. V3 20 V3 is 160. So V3 is equal to 8. Okay.
How did you
So you understand here how we got
Yeah.
1, 2. 1 is the conservation of the momentum, and 2 is the conservation of the kinetic energy. Okay? And the rest thing is just to solve the problem.
use algebra?
From the first one, we got this, the relationship between the initial speed and the speed after the collision. That's what we got from the first one. And from the second one, we got another equation. You just need to replace this variant with this one, and then you will be able to calculate.
I'm just trying to see how you have negative 20 V3. I see how you have 10 squared. That would be 100.
Yeah.
How did you get negative 20 V3?
So A minus B squared. What is this? It's A squared minus 2AB plus B squared, right? You still remember? So that's why V3 minus 10 squared, that will be V3 squared minus 2 times 10 V3 plus 100. That's a 2AB.
Right.
So it's 20
Okay.
V3. So that's algebra questions.
Yeah.
Right? Need to refresh a little bit. And then the next question. 6 kilogram object moving 6 kilogram moving to the positive direction, 2 meters per second. Has a one-dimensional elastic collision with a 4 kilogram object moving 3 meters per second to the opposite direction. What's the total kinetic energy of the two-mass system after the collision? For this one, you don't even need to calculate, think about after a collision, what's the velocity and everything, because we know the kinetic energy is conserved, initial and final, because it's elastic collision, right? So we just need to calculate the initial kinetic energy. That will be the total kinetic energy after the collision. It will be the same, right? So it's equal to 1/2 6 2 meters per second plus 1/2 4 3 meters per second, and that will be 3 times 4 12 plus 2 times 9 18, and it will be 30.
But you have to give the mass and the velocity. That has to be given.
Yeah, we have the initial one, right?
No, I'm just saying for,
For
to
this
just,
kind of question?
you have to have the mass and
Yeah.
velocity.
Yeah. And then for 13, okay, an 8-gram particle. So it's 0.08 kilogram. It's moving 50 meters per second to the x direction, positive x. And then it strikes and stick to a 0.06 kilogram particle moving to the positive y direction. Also 50 meters per second. So for this kind of question, we can think about x and y, right? Along x, we use conservation of the momentum. Along x, let's say that's A particle and that's B particle. The momentum A plus momentum B will be equal to because afterward they stick to each other, right? So it will be 1. And then we know the initial is 50, right? For B is 0 because there's no velocity along x. And that will be the momentum afterward, right? And we know this mass because they stick to each other. It will be equal to the mass A plus mass B, which will be 0.14, right? Because they stick to each other, it will be 8 plus 6, 0.14. And then this way you can calculate, because we know this, and we know this. You got velocity x is 28.57. Okay? And along y, the same thing. Here is x. Okay? Along y is the same thing. Initially, A, there is no speed along y, so it's 0. For this particle B times 50, in the end it will be the whole thing times velocity y, right? And then if you calculate equal to 21.43. And the question is asks you how much kinetic energy is lost in this collision. So first we can calculate in the end, after the collision, what's the velocity? V squared root